So in this video, we're going to talk about the limit comparison test, which is different than the comparison test. It's a different kind of comparison test because it's based on the ratios of the terms of the series. So here's a statement of the limit comparison test. Suppose we have two series, the sum from k equals 1 to infinity of a sub k and the sum from k equals 1 to infinity of b sub k. And let c be the value of the limit as k goes to infinity of the ratio of a sub k over b sub k. If that number that we get c is positive and finite, so it's greater than 0 and less than infinity, then either both series converge or both series diverge. So this tool is helpful when you have two similar looking series and you know the behavior for one of them. So here's an example. Does the sum from n equals 1 to infinity of n squared minus n converge? Now, this looks really similar to 1 over n squared. I can cover up part of this and it looks like 1 over n squared. And I know that 1 over n squared converges because it's a p-series with p equals 2. Okay, so now let's look at the ratio of these things. So we have, let's see, the limit as n goes to infinity of 1 over n squared over 1 over n squared minus n. And then let's remember that we can do a little denominator trickery here where this comes up to the top and this becomes n squared over n squared. And that's equal to 1. Okay, is this positive? Yep. Is this less than infinity? Yep. So what we can conclude is that these two series have the same behavior. So sum from n equals 1 to infinity of 1 over n squared minus n also converges. We've given a demonstration here using the limit comparison test that the answer is yes. So now let's look at another example. Does the sum from n equals 2 to infinity of 4n squared plus n plus 1 over 5n to the 7th plus n to the 5th converge or diverge? So let's look at what we would expect to happen here. This is, morally speaking, similar to 1 over n to the 5th because the leading term here is 4n squared and the leading term here is 5n to the 7th. So let's do limit comparison with the sum from n equals 2 to infinity, 1 over n to the 5th, which we know converges. So what we're going to do is we're going to take now the limit as n approaches infinity of 4n squared plus n plus 1 over 5n to the 7th plus n to the 5th over 1 over n to the 5th. And then this, we multiply that by the reciprocal of this. So this is the limit as n approaches infinity, 4n squared plus n plus 1 times n to the 5th over 5n to the 7th plus n to the 5th, 1. And here I need to distribute through. So this would become limit n approaches infinity of 4n to the 7th plus n to the 5th all over 5n to the 7th plus n to the 5th. And this is going to be determined by the leading powers here. So this ratio turns out to be 4/5. Now this is a positive finite number. So this series and this series will have the same behavior. So the answer to this is it converges. And this is an example of one where it's a lot cleaner to work with this, to work with the limit comparison test than it would be with the regular comparison test.